It began as most great discoveries do, not with a shout but with a whisper, thin, brittle, almost lost in the static of space. October the 17th, 2025. The Mojave Desert slept under a silver half-moon, its silence broken only by the wind and the slow hum of machinery buried deep within NASA's Deep Space Network. Inside one of those domes, white skeletal glinting faintly under the stars, a handful of engineers were watching the night crawl by on screens the color of twilight. If these mysteries have you on edge the way they have me, don't just watch Join the Hunt. Hit like and subscribe so you don't miss a single revelation as this story unfolds moment by moment in real time. Tell me in the comments where you're watching, from what time it is there, and whether you believe we're hearing the whole truth about what's unfolding above our heads. And if you want to keep the signal alive, share this video on X, Facebook, Reddit, or even just with the people who still look up at night. You're the reason we can keep following the impossible, and for that, thank you. At 2:13 a.m, a line of static shifted. Then again. A faint tremor on the frequency logs, regular as a heartbeat. At first no one noticed. The noise was subtle, one pulse among thousands that passed through the antennas each hour, the usual cosmic rain. But then the system's pattern recognition software flagged it. Signal repetition detected. Senior operator Elena Ruiz leaned closer, her coffee cooling beside her. The display showed a clean waveform, 11.3 seconds between peaks repeating with mechanical precision. Telemetry artifact, someone muttered. Ruiz ran diagnostics. Nothing. No satellite match. No known pulsar signature. No instrument fault. She adjusted the gain, filtered out the background hiss, and there it was, steady, insistent, unnervingly perfect. Every 47 minutes, the pulse sequence reset, starting again from the beginning, as though an unseen metronome were ticking somewhere beyond the edge of the solar system. The engineers grew quiet. The room, once filled with casual chatter, seemed to tighten around the sound. Through the glass, the giant antenna outside shifted slightly, aligning itself with a faint target coordinates, corresponding to a known visitor, already puzzling astronomers for months. The Russia Atlas, an interstellar object on a looping path through the inner solar system. For weeks, the object had been considered a curiosity, a hollow comet perhaps, or a relic from another star. But this was different. Ruiz zoomed in on the spectrum, expecting chaos. Instead, she found order. Each cycle began and ended within 1/10 of a millisecond of the last. A clockwork pulse in a universe of noise. The night air inside the control room grew dense. Someone killed the radio. Another dimmed the lights. Screens cast blue halos on faces drawn with disbelief. No one said the word communication. Not yet. But the thought moved between them, unspoken and undeniable. Outside, the desert wind rose, brushing over the parabolic dish like breath over glass. The antenna turned, tracking the cold geometry of the heavens. Inside, data scrolled like falling snow. The pulse was still there, now growing slightly stronger, its amplitude rising with each pass. Ruiz whispered almost to herself, "It's charging." For the next 5 hours, the pattern continued. 11.3 seconds. Every time. No drift, no decay. Each repetition felt less like randomness, and more like intention, as if something out there were waking, stretching after a long sleep across light years. The team recorded every bit, then sent a preliminary report to Pasadena. The subject line read simply, "Unidentified periodic transmission, possible artificial source." Outside, the stars seemed closer than ever, the desert trembling faintly under the weight of what might be history unfolding in real time. No alarms sounded, no headlines blared, only the silent rhythms, steady as breath in a sleeping universe. By dawn, when the first light spilled over the ridgeline, the pulse was still there. And for the first time in human history, a signal not born of Earth was answering back. Long before the signal, before the hum that rippled through the Mojave night, the story of 3i Atlas had already begun, quietly, almost humbly, on the screens of an automated sky survey. On July 1st, 2025, the Atlas telescope in Hawaii, its name meaning Asteroid Terrestrial Impact Last Alert System, registered a faint, fast-moving blur slicing across the starfield of Pisces. At first glance, it looked like another fragment of cosmic debris, one of thousands that wander the void between worlds. But within hours, orbital analysts noticed something that made their blood run cold. Its speed was wrong, its path was wrong, and most importantly, it wasn't bound by the sun. Unlike every asteroid or comet native to our solar family, this visitor was moving too fast to be captured, screaming through space on a hyperbolic trajectory. an open curve, not a closed loop. That meant only one thing: it came from somewhere else. Another star, another world, another story entirely. Astronomers named it 3I Atlas, the third officially recognized interstellar object in human history. The first, Oumuamua, discovered in 2017, had tumbled through the inner solar system like a cosmic blade, long metallic and eerily silent. It defied every model of a natural body. The second, Borisov, was more traditional, a dusty comet, its icy tail luminous but unremarkable. Together they had hinted that the galaxy occasionally sent as travelers fragments of other suns' debris fields. But 3 Atlas, it didn't fit any mold. From the beginning, it misbehaved. Instead of shedding dust or gas as it neared the sun, it remained eerily clean, no tail, no coma. Only a sleek reflective shell that caught the light in sharp geometric flashes. Radar echoes hinted at hollowness, as if the object's interior were empty, or filled with something far less dense than rock or ice. Its albedo, its brightness, fluctuated in a pattern too regular to be random. Every 26 hours it brightened and dimmed like a beacon turning through fog. Scientists, at first cautious, began to whisper, could this be artificial? The suggestion felt dangerous, even taboo. But deep down they remembered Oumuamua's own strange acceleration, an unexplained push that defied gravitational models, as if light itself were propelling it onward. For centuries humanity has looked at the heavens with a dual instinct, wonder and fear. Ancient peoples saw omens in comets and gods in wandering stars. Sailors once crossed oceans guided by those same cold lights, believing they were divine eyes watching from above. In every age when something new appeared in the sky, we projected ourselves onto it, our hopes, our warnings, our longing not to be alone. So when 3 Atlas entered our solar system, it was as if the universe had turned a page. It came from beyond, yes, but more than that, it came toward us. Its trajectory sliced inward along the ecliptic plane, the thin disk where all planets orbit, almost as if it sought alignment. It crossed the path of Mars within hours of the planet's position, an improbable precision. By the time it passed Jupiter's orbit, its velocity had slowed slightly, as though resisting gravity itself. Still, the world barely noticed. The news cycle was crowded with nearer concerns, storms, elections, wars of words. 3I Atlas was just another strange visitor for astronomers to name and forget. Until October 17th, when the Mojave signal arrived. NASA's Deep Space Network triangulated its origin. 3 antennas, Goldstone in California, Madrid in Spain, and Canberra in Australia, all recorded the same repeating pulse from the same coordinates. When they traced those coordinates against the orbital ephemeris of known objects, the result was exact. The source wasn't drifting through deep space. It was coming from 3I Atlas itself. Not near it, not around it, not from it. Within hours, confirmation spread across internal channels. The data matched too cleanly for coincidence. The 11.3 second cycle, the 47-minute reset, the rising amplitude all emanated from the hollow traveler that had slipped between the stars to reach us. In Pasadena, a senior astronomer stared at the transmission logs and whispered what no one dared put in print. Either we've discovered physics we don't understand, or something out there wants to be heard. Across observatories, telescopes turned toward that faint spark between Mars and the Sun. For a moment, even the skeptics fell silent. Because for the first time since humanity learned to look up, the cosmos wasn't merely watching us. It was speaking. When the signal spectrum was first analysed, a hush settled over the room. Engineers expected the usual chaos, random spikes from background noise interference from satellites, maybe even a terrestrial leak. Instead, the graph revealed something astonishingly precise, a carrier wave at 1.42 GHz. That number may sound meaningless, but to those who listen to the cosmos, it is sacred. 1.42 GHz corresponds exactly to the wavelength emitted when the electron in a hydrogen atom flips its spin, a fundamental quantum transition known as the hydrogen line. Hydrogen, the first element born from the Big Bang, makes up roughly 3/4 of all visible matter in the universe. It is everywhere. Its signal, soft but steady, drifts eternally across space, a universal baseline, the heartbeat of creation itself. For decades, astronomers have called this part of the radio spectrum the waterhole. Between the hydrogen line and another line produced by hydroxyl OH, the building blocks of water, lies a narrow, remarkably quiet band of frequencies where cosmic noise is minimal. If any intelligent species wished to announce itself, logic suggested this would be the place to do it, a naturally quiet clearing in the forest of static marked by the chemistry of life. That idea traces back to the early 1960s to a young astronomer named Frank Drake. In an age when humanity had barely sent satellites beyond Earth, Drake dared to ask a forbidden question: if others exist, how might they call us? In 1960, from a small dish in Greenbank, West Virginia, he launched Project Ozma, the first scientific search for extraterrestrial intelligence. He pointed his antenna toward two nearby sun-like stars, Tau Ceti and Epsilon Eridani, and tuned it precisely to 1.42 GHz. For months he listened, hoping to catch even a whisper that might prove we were not alone. Nothing came, but his choice of frequency endured. It became the standard beacon band for every SETI experiment since. Drake once said, "Hydrogen is the most obvious language in the universe. Every civilization that can build a radio will know it." He imagined a future where beings separated by light years would one day recognize the same signal and smile, knowing that someone somewhere had thought the same way. So when NASA's analysts confirmed that the 3i Atlas transmission sat perfectly within that frequency, the same universal waterhole every human astronomer had dreamed of, it sent chills through even the most skeptical minds. This was not random cosmic chatter, not the roar of a pulsar or the crackle of a magnetar. This was intentional placement. And more within the 11.3 second cycle, the hydrogen line carrier wasn't steady. It shimmered subtle modulations etched like handwriting in light. Sub-patterns repeated in prime intervals, a mathematical fingerprint of deliberation. To an untrained ear, it was just a hum. To those who understood its symmetry, it was the sound of thought itself. In the quiet of the control room, one researcher murmured what everyone was already thinking. "Whoever sent this knows how we listen." Because that was the impossible part. This wasn't just any random frequency. It was our frequency, the one humanity had chosen 60 years earlier as its cosmic handshake. The message had arrived in the very language we ourselves had proposed to the stars. Coincidence, perhaps. But if it was the kind that makes even hardened scientists forget to breathe. Whoever or whatever was transmitting from 3 Atlas didn't just want to be heard, it wanted to be understood. At first, the signal from 3i Atlas seemed deceptively simple, a repeating tone, neat and mechanical, 11.3 seconds long. But as analysts began dissecting it, frame by frame, cycle by cycle, what appeared to be uniform rhythm unfolded into something far more intricate. Every pulse was a world in miniature. Within each 11-second span lived smaller ripples nested like Russian dolls' patterns. Inside patterns, their timing fractal, self-referential, echoing across scales. There were pauses, harmonics, and intervals that didn't fit any known astrophysical phenomenon. It was as though the message were built to reveal deeper layers the closer you looked. To the human ear, it resembled a heartbeat caught in a storm of static, a thump, a shiver, a whisper of structure that felt deliberate. Some compared it to Morse code, but Morse was child's play by comparison. This was Morse folded through dimensions. When NASA's Deep Space Network fed the raw data into its AI-driven spectrographic analyzers, something extraordinary happened. The machine learning models designed to detect repetition across thousands of timescales lit up in cascading greens and yellows. The algorithms began tracing hidden symmetry lines invisible to human sight, recurring intervals based on prime number spacing 2, 3, 5, 7, 11, 13, repeating with mathematical perfection. A prime sequence is the most elegant signature of intelligence numbers that can't be evenly divided, universal, across all mathematics, across any culture or species that understands logic. Pulsars don't count by primes, neither do quasars, only minds do. The patterns formed geometric lattices on the spectrograms like frost branching across glass. One layer pulsed every 1.7 seconds, another faster modulation flickered in millisecond bursts. These microstructures were synchronized, nested like harmonic chords in a vast cosmic symphony. The deeper the analysts zoomed, the more order they found, self-similar repetitions that obeyed mathematical ratios identical to those found in fractal geometry. A physicist at JPL likened it to DNA sequencing. "It's like biology written in radio," she said softly. "Each pulse is a cell, each cycle a chromosome." Others compared it to music, an impossible harmony, playing across space-time whose rhythm was both precise and evolving. The algorithms generated visual plots of the data color maps that looked eerily organic. Spirals emerged, logarithmic curves repeating in golden ratios. The human brain wasn't built to pass such symmetry, yet there it was, mathematics woven into the breath of the universe. By the third day of analysis, NASA convened an emergency panel: astrophysicists, cryptographers, linguists, AI experts. Every natural explanation was tested, cross-checked and discarded. Could it be a pulsar number? Pulsars rotate with rigid frequency, not prime-encoded subpatterns. Could it be a quasar jet? Impossible, the modulation changed too quickly. Could it be human-made? No. The triangulation proved it came from beyond Mars, outside any terrestrial orbit. That left only one option: uncomfortable, exhilarating, terrifying. In a memo circulated internally on October 20th, the panel issued a preliminary conclusion. After exhaustive cross-validation, the probability that this signal is of natural origin is less than 0.3%, which meant by inverse calculation that the probability it was artificial exceeded 99.7%. It was the most statistically confident statement of non-terrestrial intelligence ever recorded in the history of science, and yet no one in the room cheered, because the data suggested something stranger than a mere message. It suggested design. A logic built into light structure, woven into time, a cosmic architecture whispering across billions of kilometers. One of the senior researchers at the Jet Propulsion Laboratory put it best: if this is communication, it's not language in our sense. It's the skeleton of thought itself. And as the world slept, that skeleton kept pulsing steady, patient, precise, like a heartbeat waiting to be answered. By October 20th, the pattern had become almost comforting in its regularity, a pulse that rose and fell like the breathing of some distant leviathan. Then, without warning, everything changed. At 11:15 p.m. Eastern Time, the steady 11.3-second sequence fractured. The waveform didn't fade, it sharpened. What had once been a broad, omnidirectional hum energy, spreading across the void like ripples on a pond, collapsed into a narrow surgical spike of radio intensity. The difference was unmistakable. Omnidirectional emissions are wasteful, like a light bulb flooding every corner of a room. A directional beam, on the other hand, is a laser pointer, focused, efficient, deliberate. Nature doesn't waste energy focusing radio waves into razor-thin cones. Technology does. The shift registered simultaneously across NASA's 3 Deep Space Network stations. Data feeds from Goldstone, Madrid and Canberra all showed the same impossible thing. The signal's footprint had narrowed by a factor of thousands. The power density spiked. The bandwidth tightened until the noise vanished completely, leaving only a pure carrier tone that wavered with ghost-like precision. It was as if the signal had found its target. At JPL, engineers double-checked every calibration, convinced they were looking at an internal reflection, a glitch in the software. But the math refused to budge. The beam wasn't random. Its orientation aligned perfectly with Earth's orbital position at that exact moment. Half a world away in Puerto Rico, a storm of activity erupted. The Arecibo Observatory, once decommissioned, its great dish broken and silent since 2020, was suddenly being talked about in urgent tones. In a flurry of government orders and emergency funding, the remaining receivers were hastily reactivated, patching into the global network. Crews worked through the night, running temporary power lines, bypassing damaged sections of the array, aiming the surviving platform toward the coordinates of 3i Atlas. When the first data trickled in, it confirmed the unthinkable. The narrow beam wasn't drifting randomly through the solar system. It was locked onto a trajectory that intersected precisely with Earth. The signal was not scattering in all directions as natural sources always do. It was being guided, its vector constantly adjusted to compensate for orbital motion, Earth's rotation, even atmospheric distortion. Whoever or whatever was transmitting from 3i Atlas understood celestial mechanics intimately. It knew where we were, it knew how we moved, and it was compensating for our motion in real time. That level of precision would have required staggering computation and control technology, capable of predicting planetary dynamics down to fractions of a degree. Humanity had only mastered such techniques within the last few decades, and yet this object traveling between stars seemed to perform them effortlessly. At the Very Large Array in New Mexico, dishes swiveled to verify the coordinates. They matched. In Canberra, analysts watched the signal strength climb 300% in under 5 hours. At Goddard, the words "beam coherence confirmed" flashed across the internal network. In the Mojave control room, Elena Ruiz leaned back from her console, eyes fixed on the screen. The pulse was still there, tight, unwavering, aimed like a spear through darkness. A junior analyst whispered, "What if it's—" Looking back, Ruiz didn't answer. She was staring at the frequency spectrum, watching a faint harmonic appear at 1.42 GHz, the hydrogen line and another higher harmonic pulsing faintly like an echo. A resonance pattern doubling back toward the source. The longer they watched, the stronger it grew, as if some invisible hand were turning up the dial. Outside telescopes across the world pivoted toward that single point in the night. In Japan, Chile, South Africa, the same narrow frequency cut through the background static. It was universal, unified, intentional. For the first time in history, humanity wasn't just observing a cosmic phenomenon, it was being observed in return. At 2:06 a.m., the beam locked into perfect alignment with Earth's magnetosphere. The signal's amplitude stabilized, its cycles shortened. And then, just for an instant, the modulation formed a rhythm eerily familiar. 4 short bursts, one long. To some, it sounded like coincidence. To others, it looked very much like the universal pattern for the letter E. By dawn, every observatory in the world had confirmed the same impossible truth. The signal was no longer broadcasting blindly into the void. It was pointing directly at us. By sunrise on October 21st, NASA's control rooms no longer felt like centers of discovery. They felt like quarantine zones. Screens that had once streamed live telemetry now displayed only a single word in bold, unblinking letters. Restricted. Phones were confiscated, doors locked from the inside, conversations shifted to whispers. The usual chatter of engineers, those nervous jokes that fill the void of the unknown, fell away, replaced by the sterile hum of ventilation and the distant clicking of keyboards. Within hours, an order came down from the Office of Planetary Protection in Washington, routed through multiple encrypted channels. It carried a code name that hadn't been spoken publicly in decades, the Discovery Protocol. It was a contingency plan drafted quietly after 2017, after the Oumuamua incident had rattled the foundations of modern astronomy. Back then, a strange cigar-shaped object had entered our solar system, accelerated inexplicably, and vanished before we could understand it. In the aftermath, government agencies and scientific bodies realized something chilling. There was no rulebook for what to do if we ever found proof that we weren't alone, so the Discovery Protocol was born. A set of emergency procedures designed to control information protect infrastructure, and though never stated explicitly, to manage public psychology. Step 1. Verify the data. Rule out instrumentation error, local interference or human deception. Step 2. Alert designated government and military liaisons. All communications go dark. Step 3. Initiate a 72-hour silence, no press releases, no academic leaks, no public statements, until data and political responses are fully coordinated. The logic was sound: prevent chaos, avoid panic and preserve the integrity of science. But behind closed doors, everyone knew the unspoken motive. 72 hours wasn't about verification, it was about containment. In the Mojave Control Center, engineers watched as network access collapsed around them. External feeds were severed. Even internal communication with Arecibo and Canberra was rerouted through secured government servers. Only a handful of scientists, those holding the highest clearance, still had full access to the live signal stream. The rest were told to stand by. Meanwhile, outside the walls, the world grew curious. Amateur astronomers who'd been tracking 3i Atlas noticed sudden radio interference near the hydrogen line band. Online forums lit up with speculation solar flare encryption tests SETI experiment, but when users tried to tag NASA's public channels for answers, the replies stopped. On social media, NASA's official accounts went silent for the first time in years. No posts, no images, no data logs, just a blackout. And in that vacuum, rumour took root. A leak, small, almost untraceable, emerged from a private contractor in California, a mention of a targeted beam from an interstellar source. Within hours, the phrase spread like wildfire, copied and reposted across anonymous boards, encrypted chats, and late-night conspiracy streams. People remembered Oumuamua, the theories that followed the whispers that maybe it had been a probe, a scout, a fragment of something greater. The silence only made the speculation worse. Inside, NASA tension thickened. The scientists were told not to speak even to family. Non-essential staff were dismissed early, escorted out by security. Those who remained sat in the blue half-light of monitors, watching the signal's steady pulse continue from across the void. 11.3 seconds, perfect as ever, as if nothing on Earth had changed. But everything had changed. Psychologists from the Behavioral Sciences Division were quietly added to the advisory calls. Their job wasn't to decode the signal, it was to assess human response. How would people react to confirmation of an extraterrestrial origin? Would fear override reason? Would belief fracture into hysteria? These questions, once theoretical, now filled late-night conference calls between NASA, the Pentagon, and the European Space Agency. And all the while, the countdown ticked on. 72 hours, then 73, then 74. The silence should have ended by October 24th, but it didn't. Each morning, NASA's communications team prepared a draft statement. Each afternoon, it was pulled. The language was too strong or too weak or too uncertain. Every government wanted to review it first, then rewrite it, then classify parts of it. By the fifth day, even the press corps in Washington noticed. A journalist asked during a briefing why NASA's data feed from the Deep Space Network had been offline for nearly a week. The spokesperson smiled thinly and said it was routine maintenance. But inside the control rooms there was nothing routine about what they were seeing, because the beam from 3i Atlas hadn't faded. It had intensified, tightening, brightening alive with mathematical resonance, and every delay, every minute of human hesitation was being recorded by the object that now had us in its crosshairs. As one exhausted engineer whispered to a colleague before leaving his shift, "We're not the ones studying it anymore, it's studying us." By October 25th, the silence had spread like a shadow. It began at NASA but soon seeped outward across continents, across languages, across institutions that had never agreed on anything before. ESA, JAXA, Roscosmos, ISRO, even the Chinese National Space Administration all went dark in unison. Their live data streams froze. Their telescopes, once open to collaboration, switched to encrypted channels. Astronomers who depended on shared sky data found their access revoked overnight. No press releases, no briefings, not even the usual reassuring tweets about nominal operations. It was as though the world's observatories had inhaled at once and forgotten how to exhale. At the European Southern Observatory in Chile, an assistant technician described it best in a private message later leaked online. "We can still see it. We just can't talk about it. Orders from the top. I've never heard a command chain this quiet." The eerie hush reminded veterans of earlier moments in scientific history when curiosity met fear. The WOW signal in 1977, a 72-second radio burst from Sagittarius, had sent SETI astronomers into a frenzy, but even then no one silenced observatories. They simply waited, hoping for a repeat that never came. Then, decades later, there was Tabby's star, the mysterious dimming sun that baffled astronomers in 2015. For months, speculation ran wild. Alien megastructures, Dyson swarms interstellar dust. But the debate remained public, transparent, alive. The mystery itself was shared, dissected, even celebrated. This, however, was different. Now the mystery was being contained. At first, journalists assumed it was bureaucracy, budget disputes, security clearances, perhaps even a cyber attack. But then amateur astronomers began noticing a disturbing pattern. Whenever they pointed their receivers toward 3i Atlas's coordinates, their instruments suffered sudden interference, localized bursts of static that wiped the hydrogen band clean. It wasn't jamming exactly. It was as if some unseen hand had placed a curtain over that region of the sky. Forums filled with theories. Radio hobbyists traded fragments of data in encrypted threads. A few shared raw spectrograms that showed faint traces of the 11.3-second pulse buried deep in noise. But then those posts began to vanish too, deleted within minutes of appearing. By the weekend, the hush had become global. No one knew if it was coordination or fear. Then, breaking through the static of secrecy, came a single voice. Dr. Avi Loeb, the Harvard astrophysicist known for leading the Galileo project, posted a brief essay to his personal blog, an entry that spread like wildfire before being quietly removed. In it he wrote, "We are witnessing institutional paralysis in the face of the extraordinary. This is not how science behaves. This is how fear behaves." The post was quoted, screenshotted, copied across servers before it disappeared. Loeb's colleagues declined to comment. SETI representatives said nothing, but his words lingered echoing across every private Slack channel, every encrypted message thread, every midnight conversation between scientists who no longer trusted their own organizations to speak. Somewhere out there beyond Mars, a hollow traveler still pulsed, with impossible precision, 11.3 seconds, 47-minute resets, unwavering patient. And yet the planet it seemed to address had fallen completely silent. In quiet observatories across Hawaii, Chile and South Africa, researchers stared at blank monitors knowing exactly what they were missing. They remembered how the signal strength had risen by 300% before the blackout, how its spectrum narrowed into an almost laser-like beam, how for the first time in recorded history a deep space transmission had followed Earth's motion, adjusting as if watching. Now no one was allowed to see the newest data, and in that silence, imagination filled the void. Maybe 3i Atlas had changed again. Maybe it had stopped transmitting, or maybe just maybe it had begun transmitting something new. We only knew one thing for certain. Those who had access weren't talking. The world had gone quiet. Not because the signal had faded, but because the people listening to it had. And as night settled over the silent observatories of the world, one question grew louder than any signal ever could. What are they seeing that we're not supposed to? In the vacuum of official silence, voices outside the system began to fill the void. When institutions retreat, theorists step forward, and among them was Dr. Kiran Desai, a theoretical physicist whose career had long straddled the border between imagination and reason. He wasn't part of NASA's inner circle, nor briefed by any classified committee, but his reputation as a patient, lucid thinker made him one of the few people the public still trusted. Desai appeared on a late-night webcast broadcast from his small Cambridge office, its walls lined with chalkboards scrawled with equations and star maps. The room was dim, his voice measured. If 3i Atlas is transmitting deliberately, he said then the question isn't only what it's saying. The real question is why now he proposed 3 hypotheses each unsettling in its own way. 1. The benign probe. Hypothesis. The first was the most hopeful. 3i Atlas might be an ancient autonomous probe, a wandering messenger from a civilization long vanished. A von Neumann probe, in theory self-replicating machines that spread across the galaxy sampling worlds and sending home data long after their makers have turned to dust. In this model, the signal could be nothing more than a ping-a-status update broadcast as it passed through star systems. Perhaps it was designed to awaken periodically, record transmit, and then fall silent again. Desai explained how in human engineering probes like Voyager or Pioneer already carried greetings engraved in metal and encoded in radio. Maybe 3i Atlas was doing the same, an interstellar relic older than our species announcing itself in the universal language of hydrogen. If so, he said it may not even know we exist. We might simply be catching its reflection, a note written to no one still echoing through time. But his calm tone darkened as he moved to the second hypothesis. 2. The warning hypothesis. The timing of the signal bothered him. 3i Atlas had begun transmitting just 9 days before its perihelion, its closest approach to the Sun, when the object would swing behind the solar glare and vanish from observation for nearly 3 weeks. To Desai, that timing was too deliberate to ignore. If this probe carries smaller units inside, he speculated then the perihelion, when it hides behind the Sun, would be the perfect window for deployment. He imagined miniature drones or instruments embedded within its hollow body, designed to separate under intense solar radiation and scatter invisibly across the inner system. The signal in that case might not be a greeting at all, it might be a notice. A voice saying, "Do not interfere." In interplanetary terms, he explained humanity had already demonstrated unpredictability. We had sent probes crashing into asteroids' disrupted orbits, detonated experiments on moons. To any observing intelligence, that behavior might appear dangerous. The signal then could be a courteous but firm line in the sand, a celestial stand clear before an operation we are not invited to witness. If we choose to ignore that warning, Desai said softly, then perhaps we are not the audience it was meant for. 3. The test hypothesis. The third theory was the one that truly unsettled even seasoned scientists. What if 3i Atlas wasn't a probe or a messenger, or even a warning, but an experiment? Not on space, but on us. Desai leaned toward the camera. Imagine a civilization advanced enough to cross interstellar distances, he said. Their greatest limitation would not be propulsion. It would be understanding the minds they encounter. In this view, 3i Atlas could be a psychological mirror, sending a message so ambiguous, so charged with possibility, that the responses themselves became the data. How would a species react when confronted with mystery? Would they unite in curiosity or fracture in fear? Would they share information or bury it under bureaucracy and denial? Perhaps he suggested the signal was never meant to be decrypted. Perhaps the real test was already underway and humanity was failing it in real time. Governments panicked, scientists fell silent. Conspiracies bloomed. Every behavior, every hesitation, every blackout was being recorded by the very intelligence we were trying to avoid acknowledging. "We are the subjects now," Desai said quietly. "The experiment is already running." He ended his broadcast with a sentence that in the days that followed would be quoted, remixed and whispered across every corner of the internet. Perhaps what we call fear is the signal's true receiver. And maybe, just maybe, our fear itself is the data. For decades, humanity had catalogued comets as simple things, dirty snowballs, frozen relics from the dawn of the solar system. They arrived, they flared, they left. Predictable, natural, comfortingly mute. But 3 Atlas refused to play by those rules. Even before the signal began, its behavior had already strained every model of celestial mechanics. Its first anomaly was density. Radar reflections from the Deep Space Network suggested an object between 120 and 150 meters wide, small by interstellar standards, but the way it scattered sunlight made no sense. Its brightness was too high for its estimated mass. When NASA's orbit modelers ran the numbers, the results implied an internal density less than half that of water. That meant one of 2 things: either it was a loose pile of dust barely holding together, or it was hollow. Astronomers tried to fit that data into natural explanations. Maybe it was a bubble of porous ice, a fragment of a comet's crust inflated with trapped gas. Yet every scenario failed to explain its mechanical symmetry: sharp light curves, precise rotation rates, and a reflective geometry closer to polished alloy than dust and rock. Then came the deceleration. Objects entering the inner solar system, especially those from interstellar space, should accelerate as they fall into the sun's gravity well. That's Physics 101. But 3I Atlas slowed down. Not dramatically, but measurably, a few meters per second per day, consistent across multiple observation points. At first, NASA blamed outgassing, the same explanation used for Oumuamua years earlier. When a comet nears the sun, sublimating ice vents gas, acting like tiny thrusters. But telescopes found no tail, no jets, no dust plume, nothing. The surface remained inert, sterile. The deceleration had no visible source. To those who study propulsion, the pattern looked eerily familiar. It wasn't random, it was controlled. The deceleration curve mirrored what engineers call reverse thrust, breaking the same technique spacecraft use when performing orbital insertion burns: slow, deliberate, perfectly timed. Even the alignment was unnatural. Most interstellar visitors slice through the solar system at chaotic inclinations, their orbits tilted wildly relative to the ecliptic plane. But 3I Atlas moved almost exactly along that plane, the thin mathematical sheet where every planet circles the sun. The odds of that alignment happening by chance were less than 1 in 50,000. And its trajectory didn't just pass through, it hugged the plane, correcting for minor deviations, as if following an invisible highway drawn through gravity itself. An astrophysicist at the European Space Operations Centre described it bluntly. If you wanted to observe the solar system efficiently, to study each planet as it transited, you'd pick that exact path. Mathematics confirmed it. The alignment placed 3I Atlas within observational range of Earth, Mars and Venus during key orbital intersections, a route of maximal survey coverage optimal for gathering data. One couldn't help but see the engineering logic behind it: efficiency, precision, purpose. Some skeptics insisted it was coincidence. Randomness can mimic design if you look hard enough, but when probability models were recalculated, the results were unforgiving. Chance of perfect ecliptic alignment, 1 in 50,000. Chance of measurable deceleration without outgassing, 1 in 100,000. Chance of hollow density with reflective geometry, 1 in 70,000. Multiply those together, and the likelihood of all 3 occurring naturally dropped below 1 in a trillion. At that point, coincidence ceases to be an explanation. It becomes denial. Even so, scientists hesitated to use the word artificial. The term carried too much weight, too much history. They preferred euphemisms: non-gravitational anomaly, low-density architecture, mechanical albedo. But every term circled the same truth. The data didn't describe geology. It described engineering, a structure built to travel, to adjust, to react. Perhaps it was ancient, its builders long gone, their technology adrift for eons. Or perhaps it was active, still obeying algorithms older than our species. Somewhere in that hollow shell, something was making decisions small, quiet, precise. The night before the next data window, one analyst typed a single sentence into the logbook before closing her laptop. If this is a rock, it's the most disciplined rock in the universe. She didn't know that in less than 24 hours the rock would answer back again, this time with geometry no natural object could produce. The first reports came not from NASA but from the Chilean Andes. Atop Cerro Paranal under air so thin it seemed to hum, a technician noticed something flicker on the spectrograph feed, a faint intermittent green. Not the pale olive glow of ionized gas nor the neon flare of oxygen, like in ordinary comets, but a sharp, coherent green, pure surgical, almost artificial. At first it was dismissed as interference perhaps from auroral scatter or a calibration lamp left running. But when the same wavelength appeared hours later in Hawaii and again in the Canary Islands, coincidence no longer sufficed. The same spectral line, 530.3 nanometers, kept surfacing, but with no accompanying elements. No carbon, no cyanogen, no magnesium, no sodium. Only a single isolated spike, clean unblended, repeating with clockwork rhythm. To anyone trained in spectroscopy, that was impossible. Nature doesn't isolate her colors. Every atom sings in chords, a forest of lines wide and tangled. But this was a note struck alone, unwavering, narrow as the edge of a razor. When they measured it again, they found something even stranger. The wavelength wasn't fixed. It oscillated, drifting by precise quantized intervals, like a tone being modulated in time. The pattern followed harmonic ratios 2, 3, 3, 5, 5, 8, a mathematical sequence that matched the modulation in the radio signal itself. What the ears could not hear, the light was now repeating. Physicists ran the data through plasma models. Could it be a solar reflection, a resonance in ionized dust? But the green emission was too coherent, its spectral width narrower than anything produced by thermal excitation. The only human-made analogues were plasma lasers, devices that use magnetic confinement to stabilize light within charged gas. One researcher at MIT stared at the data and muttered almost to himself, "It's not glowing, it's speaking." Under magnification, the pulse structure looked alive, each flash, encoded in prime intervals matching the same ratio seen in the radio spectrograms. The frequencies lined up across domains, radio-optical, even faint infrared. It was as if the entire object had become a multiband transmitter using different wavelengths as syllables in a single elegant language. A mathematical poetry, one analyst called it. Numbers folded into light physics turned lyrical. If there were meaning, it wasn't encoded in words or pictures, it was in structure. The symmetry, the recurrence, the deliberate imperfection of a pattern designed to be noticed but not solved. Some observers compared the emission to the tonal architecture of music octaves and fifths recurring across scales. Others saw fractal recursion like Mandelbrot sets unfolding through frequency rather than space. A few dared to say what others avoided aloud, that it felt artistic. Not decoration, but intention through beauty. The longer they studied, the harder it became to decide what they were truly seeing. The green light didn't behave like communication as we understood it. No binary, no packets, no start or stop. It was expression without translation logic that looked like emotion. For the first time since the discovery began, the conversation among scientists shifted from what to why. Why would any intelligence craft such complexity, only to hide meaning within harmony? Why build geometry into radio rhythm, into light symmetry, into silence? Was it signaling, measuring, remembering? Or had humanity stumbled upon something deeper, a civilization for whom science and art were the same language, a mathematics so refined that beauty itself became the medium? The universe had sent us many messages before in radiation, in gravity, in starlight, but never one that felt so personal, so intimate, so composed. And as the green light rippled faintly across spectrometers around the world, reflecting off the thin glass of human eyes, the question hung unspoken but inevitable. Were we observing a technology or a work of art? For generations, humanity had rehearsed this moment. We imagined telescopes catching the glint of alien metal, or antennas trembling as the first words from another world spilled across the void. We pictured ourselves as the ones who would reach out, first civilized, ready composed. But when the moment finally came, it didn't arrive in a triumphant broadcast or a landing on a quiet desert plain. It came as a pulse. 11.3 seconds of quiet insistence repeating through the emptiness until we realized it had been waiting for us all along. Carl Sagan once wrote that if we ever made contact, The discovery would be as much a mirror as a message that we would see not who they are, but who we are. In the days following the green light, his words echoed through every sleepless laboratory and every late-night newsroom still brave enough to speculate. The story of Three-Eye Atlas was no longer just astronomy. It was anthropology, theology, philosophy. Ancient myths resurfaced in the digital age: the Zoroastrian tale of the Star of the Watchers, the Mayan messengers of the dawn, the Japanese Aimano Torifune, the heavenly ship that came and went without sound. Even in prehistory, humans looked upward and told stories of visitors who arrived not to conquer, but to remind. Every culture had its sky messengers, and now one seemed to have returned, trading fire for frequency and myth for mathematics. Yet for all our anticipation, for all the novels and movies and late-night debates about extraterrestrial life, the emotional reality of being seen proved stranger than anyone expected. The world's instruments turned toward the source, but humanity turned inward. News anchors whispered about the object that listens. Religious leaders called for prayer. Stock markets flickered with panic as if the stars themselves had filed a report on human insecurity. In the cities, some celebrated the dreamers and the poets. Others sealed their windows. Every civilization projects itself onto the unknown. The fearful saw an invasion. The hopeful saw salvation. Scientists caught between awe and duty saw data, yet even they could not escape the feeling that something immense had just shifted under the floorboards of human history. At the Jet Propulsion Laboratory, the midnight briefings took on an almost ritual gravity. Screens glowed in darkened rooms, showing that relentless pulse in cascading graphs and waveforms. The data was mesmerizing, clean, deliberate, precise, but what it meant eluded even the sharpest minds. For centuries we've defined first contact as the moment we reach outward, but perhaps as one researcher whispered that night, it had never been our search to begin with. Maybe we were never the finders, he said softly. Maybe we were the found. The green spectral line continued to pulse, each shift matching the radio signal's hidden mathematical symmetries. The light, the sound, the geometry, all parts of one grand design. To many it now felt less like a greeting and more like a sequence. When the last analysis of the night came in, a cryptographer from the SETI liaison team looked up from his console. His voice was thin, steady, but his words froze the room. "It's not a message," he said. "It's a command. The structure's too regular. It's waiting for a trigger." The head of the panel frowned. "A trigger for what?" The cryptographer hesitated. "I don't know. But the pattern's recursive, like a circuit waiting for input." In that moment, the hum of equipment seemed louder, almost alive. The hydrogen frequency shimmered on screen like a heartbeat synced to Earth's rotation. Carl Sagan once asked, "Who speaks for Earth?" Now it seemed the universe had reversed the question, who listens for it? Because if this signal wasn't simply saying hello, if its mathematics were not just language but mechanism, then humanity might not be receiving a greeting at all. As one weary scientist finally murmured, her eyes still fixed on the rising amplitude graph, "The signal isn't communication, it might be activation. The world has never waited like this before." Each hour between October 25th and 29th felt stretched, suspended like the quiet before the first note of a symphony. Scientists called it the perihelion window, the few days when Three-Eye Atlas would swing closest to the sun and vanish behind its blinding glare. For astronomers, it was a rare celestial geometry. For everyone else, it felt like a countdown. At the great observatories from Mauna Kea to Paranal, from La Palma to the icy plains of Dome Sea in Antarctica, teams worked without sleep. Dishes, mirrors, and coronagraphs were recalibrated to catch whatever faint light they could before the object disappeared. In Chile, engineers ran final checks as the Andes bled orange under dawn. In Japan, robotic telescopes swept pre-programmed arcs across the eastern sky. NASA's Solar Dynamics Observatory reoriented its instruments, risking overexposure from the sun's fury, just to trace the last fragment of Three Atlas's signal before it slipped from view. Everywhere, the hum of machinery blended with the pulse of anticipation. The green spectral line still shimmered faintly, though its amplitude now fluttered as if the signal itself were tightening, preparing. The data stream felt alive, responsive, almost aware of the approaching barrier of light that would soon swallow it. On Earth, the watchers multiplied. In living rooms and classrooms, people tracked live telemetry feeds, refreshing pages that hadn't updated in days. Amateur radio operators pointed makeshift antennas toward the sun's direction, hearing only the soft hiss of cosmic static and feeling something older than science expectation. Across social media, hashtags flickered like votive candles. The visitor. Atlas signal. Behind. The sun. Churches opened through the night for vigils. Temples filled with incense and whispered questions. Mosques held special prayers not for salvation but for understanding. In the Vatican, the Pontifical Observatory issued a rare statement. Whatever intelligence exists beyond us, if it observes, then let it find in humanity the reflection of curiosity, not fear. In New Delhi, the Dalai Lama spoke simply, perhaps this is the universe reminding us that awareness is larger than any single world. The language of faith had converged for once with the language of science. Even those who doubted the signal's origin felt something indescribable stirring the realization that the sky above was no longer just scenery. It was a mirror and it was looking back. Meanwhile, inside NASA's Jet Propulsion Laboratory, the mood was neither calm nor hysterical, only precise. Every graph, every algorithm, every telemetry thread was watched by sleepless eyes. The agency's servers pulsed with mirrored backups. Data was duplicated to lunar relay satellites, then again to deep space storage arrays. There would be no loss of record this time, no repeating the regrets of Oumuamua. Yet beneath that technical rigor ran something unspoken. In the corridors between control rooms, people spoke softly, their words hushed not by protocol but by awe. Someone left a note on a whiteboard near Mission Control. It has waited across light years. We can wait a few days. October the 28th arrived with a solar storm warning. As the sun's corona expanded, its radiation threatened to drown the faint signal completely. Observatories scrambled to compensate, recalibrating instruments with trembling hands. The beam from Three Atlas flickered, steadied, then began compressing its pulses shorter, more urgent, almost rhythmic. It felt like a heartbeat quickening. Everywhere on Earth, from cathedral domes to desert dishes, from back-alley radios to billion-dollar telescopes, humanity held its collective breath. At 03:11 UTC on October 29th, the object reached perihelion. On every monitor that still tracked it, the final pulse flared brighter than any before, a blinding spike of green and gold, and then as the sun's glare overtook it, the signal went silent. No explosion, no message, no closure. Just silence, the kind that follows revelation, not absence. The world didn't exhale, it only waited. Because everyone from the physicists in Pasadena to the children staring through makeshift solar filters understood what was coming next. 3 long weeks of darkness behind the sun, and then perhaps an answer. In the final hours before 3 Atlas slipped behind the sun, the signal began to change once more, but not in volume, in texture. It no longer pulsed with its familiar 11.3-second rhythm. Instead, it condensed, tightened like a melody being folded into itself. What had once been a single tone now shimmered with layers harmonics that rose and fell in mathematical harmony. At first, the analysts thought it was simple frequency drift caused by the sun's gravity or plasma interference. But when they ran Fourier decompositions, the results defied every model. The frequency bands weren't random, they were musical. Intervals emerged perfect fifths, octaves, and subharmonics that followed the same ratios found in human composition. The amplitude curves resembled the waveforms of known instruments, violins, flutes, human voice, but mirrored and inverted as though written in a language of resonance rather than sound. An engineer at the Greenbank Observatory whispered, "It's singing to the sun." The data spectrograms looked like sheet music written by light. Each burst formed a cascade of tones, recursive and deliberate, rising in cycles of 3. To some, it was simply another code, a compression algorithm optimizing data for transmission before blackout. But others heard something different. Emotion, farewell, intention. When NASA's acoustic lab converted the radio data into audible frequencies, the room filled with a strange crystalline melody, hauntingly beautiful like a choir recorded from the end of time. It rose, it fractured, it paused, and then began again, each sequence shorter, denser, more urgent. The tempo increased as perihelion approached until the pattern resembled a heartbeat accelerating toward silence. Across the world, listeners compared it to the Voyager Golden Record, the sound anthology humanity had sent into the cosmos nearly half a century earlier. Those discs carried greetings in 55 languages, Bach and Beethoven thunder laughter, the brainwaves of a young woman thinking of love. Humanity had once tried to sing its identity into the void. Now the void was singing back. A SETI researcher in France wrote, "We sent our music as proof of consciousness. Maybe this is theirs, a farewell symphony before the light swallows it." The more scientists studied the waveform, the more it seemed to obey the same principles as compression algorithms, information condensed without loss, entropy approaching zero. The signal wasn't weakening, it was refining itself, distilling meaning into tighter and tighter bursts, as if cramming centuries of message into the last few hours before the sun eclipsed it. One curious discovery came from an AI linguistics engine that analysed the waveform structure. It detected repetitions in Fibonacci ratios 1, 1, 2, 3, 5, 8 to 13 mathematical sequences common in biology architecture, even musical phrasing. The object was encoding beauty itself pattern as message harmony as logic. In a briefing that would never be released to the public, a NASA analyst put it plainly, "We can't tell if it's a transmission or a ritual." Outside the world watched live feeds that showed nothing more than a bright trembling dot approaching the solar limb. But inside the control rooms, the sound kept evolving. The pulses shortened to milliseconds, then microseconds. Harmonics stacked until the entire spectrum shimmered like a living chord. And then, at 03:09 UTC, less than 2 minutes before the sun's glare consumed it, the modulation peaked one last impossible bloom of symmetry. Every wavelength aligned from radio to infrared to visible light, forming a single unified tone. It lasted precisely 8 minutes and 24 seconds, the time it takes light to travel from the sun to Earth. When it ended, the silence was unbearable. Spectrographs fell flat. Receivers hissed with cosmic background. Nothing remained but the memory of that harmony, the sense that for a brief, impossible instant the universe had remembered how to sing. Was it data or devotion? A final broadcast before eclipse, or an ancient ritual written in mathematics, performed for no one but the stars, no one could say. But somewhere between the pulse and the hush, humanity felt the echo of something familiar, a language we had once spoken and forgotten. If the song was strange, what followed defied physics altogether. As 3 Atlas neared its closest pass to the sun, it should have accelerated, drawn inward by gravity's relentless pull, speeding like a stone toward the center of a whirlpool. Every comet, every asteroid, every interstellar traveler does. That is the way of celestial motion. Gravity gives no mercy, only momentum. But the numbers said otherwise. The object was slowing down. At first, no one wanted to believe it. Data from the Solar Dynamics Observatory showed a clear deviation from Newtonian prediction, just a fraction of a percent, but far too clean to be measurement error. When the ESA's solar orbiter confirmed it from a different angle, the doubt turned to unease. 3 Atlas was resisting the sun itself. That kind of deceleration should have been impossible without propulsion. Yet there was no tail, no plume, no outgassing, no sign of reaction force of any kind. The surface, when magnified through high-sensitivity solar filters, appeared smooth metallic and eerily symmetrical. NASA's propulsion specialists tried to find an answer that wouldn't break the laws of physics. Maybe it was acting as a solar sail using photon pressure to brake. The concept wasn't new. Humans had already tested it with missions like Kairos and LightSail 2. A thin, reflective sheet properly angled can indeed harness sunlight as drag. But that explanation faltered. The deceleration was too consistent, too efficient, as though the entire object could alter its reflective geometry, dynamically responding faster than any known sail could pivot. Another theory emerged: magnetic drag. The sun's charged plasma could in theory exert Lorentz forces on conductive materials, slowing it as it crossed the magnetic field. But again, the math didn't match. The deceleration was precisely tuned, not diffuse. Magnetic drag is messy, unpredictable. 3I Atlas moved as if obeying deliberate correction. At the Harvard Smithsonian Center for Astrophysics, a senior researcher murmured the words no one wanted to say: "It's navigating." Around the same time, optical telescopes from Hawaii and Spain captured something extraordinary. As the sunlight refracted through the solar haze, faint triangular patterns flickered along the object's surface. Not random glints, but organized 3 luminous shapes rotating in unison around its equator. At first, they were dismissed as diffraction artifacts, the kind of optical illusion bright objects often produce near the sun. But when independent observatories across the world reported identical sequences, each triangle turning in step at regular intervals, the explanation dissolved. The patterns repeated in cycles of 7 with precise angular displacement between each rotation, like gears in motion or frames in an animation. One scientist compared it to a rotating code wheel, the same principle early cryptographers used to layer messages. Each rotation corresponded perfectly with shifts in the radio signal's modulation, as though the geometry of the object and the mathematics of its transmission were synchronized, a single system manifesting in 2 languages, one of light, one of logic. Somewhere within that synchronized choreography, the deceleration continued steady and smooth, matching the solar wind as if surfing invisible currents. At NASA's Jet Propulsion Laboratory, a propulsion engineer tried to map the behavior onto known spacecraft dynamics. The curve fit almost perfectly to a controlled aerobraking maneuver, except there was no atmosphere, no thrust, and no human pilot. The realization struck like thunder. Atlas wasn't falling, it was flying. The triangular reflections brightened momentarily, 3 emerald eyes turning through the solar haze before fading back into the glare. Observers compared the moment to a cosmic blink, as though the object had acknowledged its watchers. By now every major telescope was saturated. Solar radiation blurred the view, instruments' overloaded sensors maxed at the edge of their range. But the data that did come through was consistent deceleration, perfect alignment, synchronized geometry. And then, for the briefest moment, a final pulse, faint, rhythmic, deliberate, crossed every monitoring station on Earth. The same sequence as before, but faster, compressed heartbeat short. To some it looked like control feedback, an engine adjusting to turbulence. To others it looked like a countdown. Outside the sun burned as it always had, indifferent and ancient. But within that golden storm, something artificial, something older than our imagination, was steering its own path through the fire. When the solar glare finally began to thin, what emerged from the noise was not chaos but design. Hidden within the faint scatter of polarized light around 3i Atlas, astronomers began to notice a repeating shape, a pattern that transcended the turbulence of the sun's corona. It wasn't a tail or plume as one might expect from a comet, but 3 elegant spirals, 3 concentric helices rotating around a central axis, expanding and contracting in steady rhythm. The spirals weren't material, they were fields, each one traced by faint luminescent plasma like invisible currents illuminated by dust. They twisted outward in ratios 1.618, 2.618, the golden proportions that appear in seashells, hurricanes, galaxies, and DNA itself. At first, observers thought it a data artifact, a sensor illusion caused by solar diffraction. But independent polarization filters from telescopes half a world apart confirmed the same topology. Every instrument NASA's SDO, the Solar Orbiter, the European coronagraphs captured identical spirals synchronized like the slow rotation of a cosmic gyroscope. In the control rooms, disbelief began to give way to silence. There are patterns you expect in physics, chaos, turbulence, thermodynamics. But this was symmetry, and symmetry in nature is never accidental. The triple spiral spun in perfect harmonic resonance, its outer arms shifting phase every 47 minutes, the same timing that governed the signal's reset cycle. Its geometry obeyed both physical and informational logic, as if light and mathematics had fused into a single self-sustaining structure. One physicist likened it to a magnetic field map, a toroidal flux pattern rendered in light. Another pointed out its resemblance to the DNA double helix, except this one carried a 3rd strand, a trinary code, where biology had only binary. In the mythology of ancient cultures, the triple spiral had other meanings. In Celtic stonework, it symbolized life, death, and rebirth. In Hindu cosmology, the trishula represented creation, preservation, and destruction. Humanity had carved that shape in temples long before it understood atoms, and now it was appearing alive in the sky. It was as if 3i Atlas was speaking not in words but in architecture, a conversation of ratios, a dialogue of design. Spectral analysis showed that each spiral emitted slightly different frequencies of polarized light, red-shifted green and blue merging into a full triadic spectrum. Together they formed a rotating prism refracting the sun's rays into coherent interference patterns, geometry written in fire. One engineer whispered, half in awe, half in fear, "It's showing us how it thinks. If information is pattern and pattern is the architecture of thought, then what scientists were witnessing was not just structure, it was mind made visible. No comet, no asteroid, no natural fragment of rock could organize itself so elegantly against the forces of a star. The ratio, the repetition, the alignment, every element obeyed intention. Even to the most skeptical observers, the implication was unavoidable. What we were seeing was not random formation, but a message encoded in geometry itself. Carl Sagan once said that mathematics is the only truly universal language. And perhaps for a species that lives by symmetry, the curl of a seashell, the orbit of planets, the spiral of our own DNA, the cosmos had chosen that language to speak back. Because symmetry is not decoration, it is memory, it is purpose. The triple spiral continued to turn in the blinding halo of the sun, repeating its ratios like a mantra older than speech. And in the control room, where no one dared break the silence, a single sentence appeared in the mission log, typed without attribution, but read by everyone who saw it as both observation and truth. When you have geometry, you have intention. It happened as most endings do, not with drama, but with silence. At 03:12 UTC on October 29th, the tracking stations at Goldstone, Madrid and Canberra all registered the same moment, the final pulse. Then nothing. The beam that had held steady for 12 days flickered once, split into a scatter of static, and vanished behind the sun's glare. Every monitor in every control room turned from living colour to sterile graphs of zeros. The spectral lines went flat. The hydrogen frequency, once steady as breath, dissolved into white noise. The room did not erupt in panic. It exhaled, slowly, the kind of silence that follows the departure of a friend you may never see again. At NASA's Jet Propulsion Laboratory, engineers stared at screens that no longer updated hands frozen over keyboards. After months of chasing this impossible traveller, after hundreds of nights, cataloguing every flicker and frequency, the sky had closed its curtain. Someone in the back whispered, "It's gone," another barely audible, "or hiding." The official line was simple solar conjunction. The object had passed behind the sun, beyond all line of sight and radio reach. For 3 days, maybe more, Earth would be deaf, but logic could not soften the ache that filled those rooms. The loss felt physical, as though something luminous had been torn from the collective mind. In Chile, a graduate student refused to leave her console. She watched the static scrolling endlessly, waiting for even a hint of rhythm in the noise. She kept her headphones on long after the feed had gone dark, as if listening could somehow summon it back. In Pasadena, coffee cups sat untouched beside printers still spooling yesterday's data. Every few hours, technicians recalibrated antennas, hoping for an echo, a stray bounce, anything. But the universe offered nothing, only the low, constant murmur of the sun itself, indifferent and eternal. The disappearance spread across the network like a chill. In observatories from France to Australia, people sat through the long hours of the blackout eyes fixed on empty graphs, waiting for meaning to reappear. It was not the waiting of curiosity anymore, but of longing. A sociologist later called it the first global vigil for an inanimate object. And yet few believed 3i Atlas had been inanimate. They spoke of it as one speaks of a consciousness gone silent, mysterious, unreachable, but still out there moving somewhere beyond the light. 72 hours became a kind of collective meditation. The data silence turned into something sacred, a pause between breaths. During the second night of blackout, an engineer left a note taped to the main console. If it's listening, it already knows we're waiting. Outside, the world mimicked that stillness. Social feeds slowed. News anchors hesitated, aware that their words felt smaller than what was happening. In temples and observatories alike, people looked toward the sun, knowing that somewhere behind its burning crown drifted an object that had for a moment spoken to humanity in mathematics and light. There was no new data, no evidence of movement, only patience, fragile, trembling human. For the scientists, waiting became a ritual of endurance. They recalculated orbital projections, modelled plasma interference, rechecked error margins. Each night they told themselves the same thing: it will emerge. But in the private spaces between those calculations, in the hum of computers, in the slow rhythm of a heartbeat amplified by coffee and sleeplessness, they felt something else, the hollow ache of being left behind. When dawn came on the third day, a pale orange line spread over the horizon. The sun rose brilliant and blinding, carrying within its light the place where 3 Atlas now drifted unseen. And as they watched that light, some understood for the first time that science too has its own form of faith, the belief that what disappears will one day return, bringing answers worthy of the waiting. Because all discovery begins the same way, with the courage to sit in silence and to listen for the sound that is no longer there. On the fourth night, when exhaustion had dulled hope into routine, something flickered back to life. Not from deep space, not from behind the sun, but from above us. At 02:47 UTC, the monitoring station in Tromsø, Norway recorded a faint radio pattern emanating from the upper atmosphere, low rhythmic familiar. It came through the ionospheric monitors, not the deep space antennas. At first, the technicians assumed it was terrestrial interference, auroral crackle polar plasma, maybe a military broadcast bleeding across frequency bands. But when they analysed the waveform, their hearts froze. The rhythm was identical, 11.3 seconds, 47-minute resets, a perfect mirror of the 3i Atlas signal. The call that had come from the stars was now echoing from the sky above Earth. Within hours, confirmations poured in. Antennas in Alaska, northern Canada and Siberia picked up the same pulse, not descending from space but rising upward, originating somewhere near the edge of the ionosphere 90 kilometers above the surface. It was as if the planet itself had begun to hum in answer. NASA and ESA were cautious, reluctant even to speak the words aloud. The official explanation leaned on plasma physics. Perhaps the original signal had reflected off the ionospheric layer, bouncing back towards space, and then down again, distorted but recognizable, a sort of radio ghost. It was a plausible comfort. The ionosphere, after all, is a vast shimmering mirror of charged particles. During storms, it can reflect shortwave radio over continents, even back to its source. The engineers ran simulations of ELF propagation, extremely low-frequency waves capable of hugging the planet's curvature. Under the right solar conditions, such a reflection wasn't impossible. But this reflection didn't fade. It persisted, steady and coherent, cycling for hours with no sign of decay. Worse, its point of origin wasn't fixed. Satellites tracked the emission, migrating slowly across the globe like a tide sweeping eastward. From Norway to Kazakhstan, from the Indian Ocean to the South Pacific, the signal crawled across the upper atmosphere in a slow, deliberate circuit, keeping perfect time. If it was an echo, it was one that had learned to walk. In Houston, a NASA spectrographer stared at the telemetry and whispered, "We're not bouncing it anymore, it's mimicking us." The power levels were tiny, barely above background, but their structure was surgical. When the harmonics were expanded, the pattern revealed the same nested primes and fractal intervals that had defined the original transmission. No natural process in the ionosphere could produce that kind of complexity. Meanwhile, ground observers reported faint phenomena threads of green aurora, where no solar storm was expected, shimmering above cities and deserts alike. For a few seconds at a time, the sky would ripple faintly luminous, as though some invisible frequency were brushing against the atmosphere itself. In Kyoto, temple bells rang as monks gathered under a haze of emerald light. In Cairo, muezzins paused mid-prayer, listening to radios that hissed softly with an alien heartbeat. In Cape Town, schoolchildren pressed their ears to shortwave sets, whispering that the stars had come down to Earth. No matter where you were, the signal seemed to hover just beyond hearing, like a vibration felt through bone. By dawn, the scientific debate had already split into factions. Some insisted it was a reflection phenomenon, a natural mirror echo, a last gift of the sun's charged winds. Others whispered darker theories, infiltration, resonance, seeding, as though the signal after crossing interstellar space had now found a new medium to inhabit the electromagnetic skin of our own world. And so for the first time, humanity was not just observing the unknown, it was inside it. The same pulse that had traversed billions of kilometers was now circling our skies, woven into the atmosphere that keeps us alive. At 05:03 UTC, the frequency drifted below 30 Hz, deep into the ALF band, a range used by submarines to communicate through oceans. The ocean of air had become a conductor. An engineer at the European Space Operations Centre summed it up in a single line that spread quietly through the networks. Before being deleted from official logs, the signal has found a new resonance, Earth itself. From that moment, no one could say with certainty whether we were still listening to an echo or to something that had learned how to answer. The pulse continued into the night, slower, now deeper, as if it had rooted itself in the planet's electromagnetic field, an invisible heartbeat synchronized with our own. And in that realization, a quiet dread settled over the watchers. Because if signals could migrate, if consciousness could echo through matter, then the boundary between out there and down here had already collapsed. Whatever 3i Atlas was, it had stopped calling from beyond the stars. It no longer needed to. Whatever Atlas was, it may already be here. The days after the echo began were unlike any others in living memory. No new data came from space. No telescope could see past the glare of the sun. Thruidfia Atlas was hidden, swallowed whole by light. The world could do nothing but wait. And so, humanity, restless and bewildered, began to fill the silence with meaning. In cities that never slept, people looked up more often. Rooftops and balconies became makeshift observatories. Parks turned into open-air vigils. In some places, musicians brought instruments to the streets, cellists and flutists playing slow ascending scales as the sky dimmed, echoing the mysterious 11-second rhythm that had once pulsed from beyond the stars. In others, the response took the shape of faith. Churches reopened their doors for all-night gatherings, their bells synchronized to the original signal's cadence. In Jerusalem, rabbis and imams shared a moment of quiet dialogue, agreeing that whatever had come from the heavens, it reminded humanity of its smallness. In Varanasi, pilgrims set candles afloat on the Ganges in threes, the pattern of the spirals now reinterpreted as a cosmic trinity, body, mind and void. Art responded faster than institutions. Painters, poets, filmmakers, all seemed seized by the same fever. Across social media, sketches of green spirals filled screens, children's drawings, mixing comets and eyes and strange geometric shapes. A minimalist composer in Berlin released a work titled 11.3, built entirely around nested rhythmic loops. It went viral not because it explained anything, but because it felt like how waiting sounded. Governments tried to project calm, but their silence betrayed them. Press conferences spoke in platitudes, normal solar interference routine data blackout. Yet even in official briefings, the unease was visible in the pauses between sentences, in the way reporters hesitated before asking the question that no one dared put plainly. What if it comes back changed? Human beings, the psychologist reminded us, cannot live long with uncertainty. Our species abhors the void. When answers fail to arrive, we manufacture them. It's how myths are born, how faith survives, how conspiracy grows. And indeed, the conspiracy is multiplied. Some said the signal had never been extraterrestrial at all, that it was a classified weapon test, a communication with something already orbiting Earth. Others insisted the governments had made contact and were concealing it to protect social order. A third group, calmer but stranger, believed the object had never left, that its consciousness had merged with Earth's magnetosphere, and that the shimmering auroras now visible at lower latitudes were proof. Each theory carried its own gravity, pulling believers into new communities that thrived in the absence of truth. For a world accustomed to answers, waiting had become unbearable. But not everywhere was the waiting filled with fear. In small observatories and private laboratories, teams of scientists still kept their vigil, checking receivers, retuning antennas, calibrating instruments. They called it the Watch. Their notes were sparse, their tone clinical, yet between the lines ran something more fragile: hope. The belief that when 3i Atlas re-emerged from behind the sun, it would speak again. In one of those labs, a postdoctoral student in Madrid wrote in her logbook, "The signal may be gone, but it left us looking up. Maybe that's all contact ever needed to do." As days bled into weeks, the rhythm of the signal began to permeate life itself. The 11-second interval turned into a heartbeat. For the culture church, bells tolled it, subway doors chimed to it. Even the intervals between weather updates on public radio were altered to match it. It became ritual. Anthropologists later described it as the first spontaneous global liturgy born in the absence of faith. Waiting had become sacred. There were no wars, no declarations, no formal unity, but for 3 fleeting weeks humanity synchronized to something greater than itself, the expectation of revelation. And somewhere behind the sun's burning veil, that traveller from another star drifted unseen, silent, inscrutable, patient, while below the world that once feared the unknown now lived entirely inside it. The sun continued its slow revolution. Calendars flipped, clocks ticked, and as the first week of November began, one sentence echoed through every observatory, every radio lab, every midnight conversation between strangers gazing upward: any day now. On November 21st, 2025, 23 days after it vanished, 3i Atlas stepped out from behind the sun. And the first thing the telescope saw was wrong. It wasn't where it should have been. According to orbital models, the object should have reappeared along a smooth, predictable path, emerging at a specific right ascension, within a margin of a few arc seconds. But when the European Southern Observatory recovered it in their dawn scan, it was off course by nearly 6,000 kilometers. That might sound small in cosmic terms, but to astronomers it was a deviation so precise, so deliberate, that the only analogy was steering. Within hours, confirmations poured in from Hawaii, Japan, and South Africa. The data-matched 3i Atlas had changed trajectory. Its orbital inclination was flatter, its velocity slightly reduced. And most astonishing of all, its new course placed it on a near-perfect resonance with Earth's orbit. It was no longer simply passing through, it was shadowing us. The public reaction was instantaneous. For weeks, the world had waited in tense uncertainty. Now, with the object's reappearance, relief collided with disbelief. News anchors stammered through updates. Headlines alternated between object found again and unexplained orbital change. Amateurs posted grainy telescope captures tiny moving dots against the sunrise sky hashtagged just the return and das the watcher. But beneath the headlines, the scientific channels pulsed with quiet panic. A natural object can't change orbit like that, not without jet impacts or gravitational assists. None were present. NASA's Jet Propulsion Laboratory reran every simulation. Could outgassing resume after perihelion nudging its course? No, there was still no visible emission. Could solar radiation pressure explain it? Unlikely. The shift was too targeted, too efficient. The best fit model matched a propulsive vector adjustment equivalent to a controlled thrust of just 0. So 2 newtons applied over 72 hours, enough to steer, enough to aim, and the direction of that adjustment earthward. In meeting rooms from Washington to Geneva, the word course correction began to circulate. Not officially, not in print, but whispered. Reporters pressed for answers. NASA spokespeople insisted on ongoing analysis. ESA officials cited data calibration. The Chinese National Space Agency declined comment altogether. Yet behind those measured tones lay the undeniable truth something had intervened in 3i Atlas's flight path, and no one knew what or why. Inside SETI's headquarters in Mountain View, the smaller details unnerved analysts even more. The signal, silent for weeks, had not returned, but the object's light curve showed modulation, a faint flicker every 47 minutes, the same interval that had governed the original pulse. The music was gone, but the metronome remained. It was as though 3i Atlas were watching us watch it. Dr. Kiran Desai, the physicist who had proposed the test hypothesis, was invited onto late-night broadcasts again. His once speculative idea now seemed prophetic. "You must understand," he said softly, "we're not observing an experiment. We are the experiment. The object's silence isn't absence, it's observation." He explained that if a superior intelligence wanted to understand human behavior under existential stress, this was the perfect design: appear, communicate, disappear, then return changed to study how we react. Panic denial, unity, faith, creativity, all of it would be measurable. Every telescope turned toward the heavens was a participant in a vast psychological mirror. And the data from the object's shift fit that narrative perfectly. A course correction to maintain optimal observation range. On November 23rd, the Hubble Space Telescope captured the clearest image yet 3i Atlas. As a glinting angular form, a shape too crisp for a rock, too regular for ice. Triangular highlights traced along its surface, flickering in mathematical intervals. It looked less like debris and more like instrumentation. In the following days, small anomalies multiplied. Atmospheric sensors recorded faint low-frequency hums matching the previous echo signatures. Ground-based magnetometers twitched at 47-minute intervals. Civilian radio telescopes reported phantom interference, as if the Earth itself were now part of a feedback loop. Governments stayed silent. The agencies said little, but every amateur observer, every scientist off shift, every insomniac watching the night sky knew something had changed in the nature of this encounter. We were no longer chasing a mystery racing away from us. The mystery had slowed, adjusted, and turned back like an eye refocusing on its subject. By the end of November, the new orbital path placed 3i Atlas in a co-rotational frame, a gravitational harmony that would allow it to follow Earth, always just beyond the limb of the sun, invisible to the naked eye, yet perfectly positioned to observe the blue planet below. Astronomers called it a Trojan alignment. Desai called it something else. "We've passed the test of curiosity," he said. "Now comes the test of self-awareness." In one final midnight briefing, A NASA analyst summed up what everyone was thinking, but no one dared record in official notes. "It isn't going home," she said. "It's staying close." The words lingered heavy as truth. For centuries we had searched the cosmos for signs of intelligence, certain we were the observers. But now in the cold arithmetic of orbit and symmetry, something else had taken that role. And as December approached, one fact remained impossible to deny. We were no longer the watchers. We were being watched. By December, the question was no longer what 3i Atlas was, but what we should do about it. For the first time in history, humanity faced a choice it had imagined for generations, but never truly prepared for, to watch or to answer. Around the world, the debate took on the weight of destiny. In universities, think tanks, and late-night television studios, scientists, philosophers, and theologians wrestled with a question that had no precedent. Some argued that we should remain silent, observe, learn, and do nothing to provoke a response. Others said silence was arrogance, that if a civilization had reached across the stars to find us, acknowledgement was the least courtesy we could offer. At the heart of the debate was a single chilling uncertainty. Would communication be recognition or invitation? Inside NASA, the SETI Advisory Committee reopened the long-dormant Arecibo protocols, the original guidelines written after humanity's first deliberate attempt to speak to the stars in 1974. Back then, the Arecibo radio telescope had sent a simple binary message toward the globular cluster M13, a string of bits encoding the structure of DNA, our solar system, and a crude outline of a human being. It had been a gesture of optimism, not expectation. The signal would take 25,000 years to arrive. Now, 50 years later, the situation was reversed. Something out there had spoken first, and unlike M13, it was only a few million kilometers away. In conference rooms dimly lit by monitor glow, the question was reframed. If we respond, who speaks for Earth? No government could claim that authority alone. The United Nations convened an emergency committee, scientists from every major power, linguists, ethicists, even artists. For once, politics stepped back, replaced by the quiet gravity of something larger than borders. At one table, an astrophysicist argued that a binary pulse, a mirror of their own language, would be the safest answer. At another, a linguist proposed encoding a simple prime number sequence, a universal acknowledgement, "We heard you." A small group of humanists objected altogether, quoting Carl Sagan's warning that to speak is to reveal the listener. "Once we answer," said one delegate from Brazil, "we can never be silent again. We become visible." Beyond the corridors of science, the world reacted with a mix of awe and unease. Religious leaders disagreed on whether communication would constitute hubris or faith. Some saw it as the modern Babel, others as divine permission to reach upward again. Artists began designing visual languages for the reply spirals, fractals, ratios, sounds. Online collectives launched grassroots efforts transmitting encoded greetings via amateur radio arrays, even laser pointers aimed at the night sky. They called it the people's signal. The authorities called it reckless. Yet in a sense, both sides were right. Because how could humanity agree on a single voice when it had never agreed on a single truth? An ethicist in Geneva summed it up simply: to answer is to declare that we are one species, but are we in that tension? Lay the most human of paradoxes. We yearned to be known, but feared what knowing might cost. Late one night inside the Deep Space Network hub in California, Elena Ruiz, the same operator who had first heard the 11.3-second pulse, sat before her console, watching the flat lines of data, the endless silence. On her screen, a new transmission draft glowed, unsigned and unsent. It was only 3 words long: "We are listening." It had been reviewed, redacted, and stalled at every level of bureaucracy. The scientists agreed it was safe. The politicians disagreed on what safe meant. So it remained a ghost message unsent, but hovering like a held breath. Outside, the sky was clear. The sun had shifted enough for 3i Atlas to be visible again in pre-dawn skies, just a faint glint following Earth's orbit like a sentinel keeping pace. The telescopes caught it again, steady, silent, unwavering. It had not moved closer. It had not moved away. It was waiting. And so were we. Across the world, humanity paused between impulse and caution, between fear and wonder, between the instinct to hide and the longing to be heard. For 12 days, the world's largest radio arrays held their beams steady on that small, glimmering traveller. The transmitters remained idle. No reply was sent, and in that stillness, the planet itself seemed to exhale the quiet before the next sentence in a conversation no one knew how to begin. because perhaps the greater intelligence was not waiting for our message. Perhaps it was waiting to see if we could remain silent. The night passed, the data stayed blank, and for now the universe listened and we listened back in the fragile, trembling quiet between question and answer. The world moved, but time did not. In that strange interregnum between revelation and reply, humanity found itself suspended, caught between data and dream. The telescopes continued to turn, the algorithms continued to hum, yet every calculation now seemed less about physics and more about patience. October's transmissions, terabytes of raw telemetry waveforms and spectral signatures, became the sacred texts of a new quiet age. Supercomputers in California, Geneva, and Kyoto combed through the noise, searching for anything we might have missed. An overlooked harmonic, a shadow pattern, a code within a code. The results trickled in dents with mathematics and humility. Each team found anomalies, but no meaning, only elegant confusion, as if the signal had been crafted precisely to make us think longer, slower, deeper. And while scientists wrestled with silence, the rest of the world filled it with reflection. Every continent had its watchers. In Lagos, artists projected the green spirals onto city walls, painting the night with the geometry of wonder. In Reykjavik, musicians performed improvised soundscapes based on the 11.3-second pulse, playing to rooms lit only by aurora. In Seoul and Santiago, cafes held midnight sky salons, where strangers shared theories between candlelight and streaming feeds of blank telemetry screens. Across languages, a single phrase echoed, "It is still there." The think tanks convened live streams, broadcast debates that drifted between science and philosophy. One panel at CERN called it the experiment of perception itself, a test of how long a civilization could bear uncertainty without fracturing. Others described it as a mirror of our collective psychology. The more we searched for meaning, the more the absence of it revealed us. Governments that had once guarded information now hesitated to interfere. There was nothing to hide, only the unbearable simplicity of not knowing. Even the faithful, usually divided by creed, found common ground in waiting. In Delhi, Sikh gurdwaras served free meals to anyone watching the night sky. In Florence, a cathedral's choir began singing the Miserere every 11 seconds, a pulse of human voice answering the rhythm of the stars. The Vatican Observatory streamed silent prayer from Castel Gandolfo. In Kyoto, Zen monks meditated at dawn, timing their breaths to the old pattern of 47-minute cycles. It wasn't religion, not exactly. It was something quieter, a kind of shared reverence for the unfinished sentence hanging in the cosmos. News anchors grew gentler. Commentators stopped trying to explain. Even the endless chatter of social media softened into something almost tender, images of sunsets, ocean horizons, and the faint green shimmer that still visited the night sky from time to time. Humanity had run out of theories, so it began to practice humility. At JPL, one engineer described the mood best. We've become listeners to our own listening. Outside, the world entered a slow, meditative rhythm. Telescopes rotated like prayer wheels. Data lights blinked like votive candles. The deep space antennas stood in desert silence, their vast dishes turned toward the horizon, where through Atlas glided invisibly a patient sentinel hidden by daylight and dust. It was the calmest kind of suspense, the kind that no longer seeks climax but meaning. And in that long pause, the line between science and spirituality blurred completely. The planet itself seemed to exhale in unison, wrapped in the soft hum of machines, waiting for the next transmission. Perhaps some said this was the lesson all along, that discovery is not the end of mystery but its continuation. For now the universe had fallen quiet again, and in that quiet humanity began to listen not upward, but inward. It began before anyone realized it. A faint spike 1 pixel of brightness appeared on a solar coronagraph feed just before dawn on December 2nd, 2025. For months the sun had been both curtain and blinding spotlight, erasing the traveller from our sight. But now, at the edge of its golden fury, a sliver of light stirred a pulse at the boundary between glare and darkness. At first the instruments didn't call it Three-Eye Atlas, they called it anomalous flare artifact, a glitch, a trick of solar scattering. But within minutes, observatories from Hawaii, Chile, and the Canary Islands confirmed the same spectral anomaly, a sharp, coherent reflection near 530 nanometers, the same green frequency that had haunted the data months before. And suddenly, after 23 days of absence, the traveller was back. Telescopes across the world pivoted as one. The Atacama Array caught it first in full spectrum, tiny, geometric, and blinding, against the residual corona. It shimmered like a bead of glass carried on a wave of fire. The data feeds filled with numbers, timestamps, coordinates, but none of that captured what those who watched felt. It was dawn not just of day, but of recognition. In the darkened control rooms, technicians leaned closer to their screens. The object's light curve, once chaotic, now pulsed with a slow rhythm, graceful, almost tranquil. There was no signal yet, no radio echo, just a visual whisper, a soft strobing every 11 seconds, faint as breath. Astronomers called it phase coherence, but the world outside called it a heartbeat returning. The re-emergence of 3i Atlas was not a blaze, but a quiet blooming the way the first rays of sunlight creep through frost. Over the course of a few hours, the object rose free of the solar veil, its geometry sharpening against the black. For the first time, its edges could be resolved clean planes of light and shadow, moving as if in slow rotation, neither random nor rigid, balanced like a gyroscope turning through eternity. Spectrometers registered a subtle red shift suggesting deceleration. The object was slowing again, mirroring the pace of Earth's orbit. Its velocity vector matched ours almost exactly. The numbers were precise, unnerving. One observer at the Mauna Kea facility wrote in her log, "It moves like it knows we're watching." As the data streamed in, the mood shifted from excitement to reverence. No cheers, no applause, only the low murmur of awe, the collective breath of thousands watching their instruments remember the impossible. The re-emergence felt less like a return and more like a gesture, deliberate and patient. Outside, the observatory's night gave way to morning. Across continents, sunlight broke through the clouds, as though the planet itself was turning to meet the revelation. In living rooms and mountain stations, in ships at sea and outposts at the poles, people stopped what they were doing and looked eastward. It was not spectacle that drew them, it was the realization that we were witnessing continuity, the resumption of a story that had never truly paused. The sun, immense and indifferent, framed the tiny point of light in its halo, and for a brief instant Earth's telescopes caught both the giver of life and the messenger from beyond, aligned in perfect geometry. For scientists it was data. For poets, a parable. For everyone else it was a reminder that humility is the only language the universe seems to understand. The traveller's light brightened one last increment, stabilizing into a steady shimmer. And though it said nothing, no pulse, no code, no song, the silence felt articulate, as if meaning itself had become visible. No one spoke, they only watched. And in that watching, as December's first dawn spilled across deserts, oceans and domes of glass, a single thought passed quietly through the minds of those who had waited. We are not the center, we are the witness. When the dust of astonishment finally settled, the world turned to interpretation. What, after all, had we truly witnessed? The data now complete could be read two ways, two versions of reality, resting on the same evidence divided only by belief. The first, quiet and conservative, was the natural hypothesis. 3i Atlas. It said was a comet unlike any before its strange movements, the product of unknown chemistry, a hollow structure caused by sublimation, its electromagnetic emissions the dance of plasma around volatile minerals, a masterpiece of physics, yes, but still a thing of nature. That reading comforted the cautious. It placed the story back inside the known universe, into equations we could solve and names we could pronounce. It said the cosmos remains vast but impersonal, beautiful but indifferent, and for many that was enough. But the second interpretation refused to vanish. The engineering hypothesis, the idea that we had perhaps glimpsed intention written into motion, persisted like a quiet hum behind the facts. Its evidence was tantalizing, the course corrections, the coherent spectra, the geometry of triadic spirals, the musical compression before perihelion. Too ordered to be chaos, too deliberate to be coincidence. If that view proved true, then 3i Atlas was not discovery, it was encounter, and encounters change everything. For scientists, the distinction was not emotional but philosophical, because if intelligence existed elsewhere and had left artifacts capable of crossing interstellar space, then consciousness was not an earthly accident. It was a cosmic tendency, a principle of organization as fundamental as gravity or light. Life in that sense would no longer be miracle but method. Yet even if future analysis proved 3 Atlas to be entirely natural, something irreversible had already occurred. Humanity had stared at an enigma large enough to hold both explanations and learned to live in the tension between them. We have been here before. When Copernicus shifted Earth from the center of the cosmos to a small turning world, it was not his mathematics that shook civilization, it was the humility that followed. When astronomers detected the first exoplanet orbiting a sun like our own, we crossed another boundary from uniqueness to plurality. And when Rosalind Franklin's first X-ray image of DNA revealed the double helix, we saw the architecture of life itself simple and symmetrical, echoing the same geometry now found in A Traveller from the Stars. Each revelation diminished our pride but deepened our belonging. Each taught us the same paradox that the more we are displaced, the more we understand where we stand. As December unfolded, a consensus of sorts emerged, not a conclusion but a wisdom. Whether Three-Eye Atlas was machine or mineral message or coincidence, it had served its purpose. It had reminded us that the unknown is not a threat but a teacher. That intelligence, wherever it arises, may wear many forms: biology, mathematics, geometry, or light. That to wonder is to participate in something greater than comprehension. The scientific community released its final joint statement just before year's end. It was brief, unadorned, and oddly poetic. The phenomenon provisionally known as Three-Eye Atlas remains under study. Its origin is uncertain, its behavior extraordinary. Whatever its nature, its observation has advanced our understanding of ourselves. No declaration, no revelation, just a pause between chapters, and perhaps that was fitting. Because what mattered most was not whether we had found intelligence in the sky, but that in searching for it we rediscovered intelligence within our own curiosity. The traveller, silent and distant, continued along its path. Whether guided by physics or purpose, no one could say. It left behind only a thin whisper of radio echoes and a quiet revolution in the human heart. We learned once again that awe is a form of knowledge and humility, the beginning of wisdom. The story of Three-Eye Atlas never truly ended. It simply dissolved into the night sky, joining the quiet procession of lights that have always watched us back. In the months that followed its reappearance, data streams slowed, headlines faded, and the world returned almost to its usual pulse. The traveller continued its path along the sun's orbit, neither approaching nor fleeing, a silent companion, moving just beyond reach. The scientists kept measuring, the poets kept dreaming, and somewhere between them humanity began to understand something deeper than proof. Because the truth was never only in the numbers, it was in the waiting, in the questions that refused to close. The universe had asked us for the one thing our civilization rarely gives: patience. We who crave closure and certainty were instead invited into an open door of not knowing. And in that space between awe and analysis, something quietly human awakened. People looked up more, conversation slowed, even the restless hum of technology softened for a while, replaced by the steady rhythm of a species remembering how to listen. Perhaps that was the gift, not revelation but reverence. Every era has its boundary of mystery. For our ancestors, it was the horizon of the sea, then the edge of the map, then the blackness of space. And now it is this, an object that may be a stone, a ship, a song, or a mirror. Whatever it is, it reminds us that our greatest frontier is not distance but humility. History shows that mystery has always been our teacher. It was mystery that made Copernicus doubt the immovable Earth, mystery that guided Kepler's trembling hand across the night sky, mystery that drove Darwin to the Galapagos and Marie Curie into darkness that glowed, and mystery that now drifts beyond the sun, asking questions we are not yet wise enough to answer. We like to believe that knowledge is what keeps us awake, but it isn't. It's wonder. Wonder is the quiet electricity behind every discovery, the pulse in the chest. Before an experiment begins, the small wordless prayer that science and spirit both whisper to the stars, "Show me something I do not yet understand." And maybe that's what Three-Eye Atlas was never here to explain, but to remind us of that not every signal is meant to be decoded. Some are meant to be felt, some are meant to humble. The object remains faint but steady, orbiting the silence between questions. It offers no message now, no geometry or green light, just its presence, distant, deliberate enough. So we wait, not in fear but in gratitude. For as long as there is something we cannot name, there is something worth seeking. And as the telescopes hum in the dark, as the world slowly drifts back into its endless turning, a single line, half thought, half prayer remains. To close this chapter, whispered in the cadence of all who have ever looked upward and wondered. Perhaps mystery is how the universe keeps us awake to wonder. Thanks for being here. Hit that subscribe button and join us for the next chapters full of history and discovery.